Imagine you've deployed an ESP32 in a smart greenhouse measuring soil moisture and temperature. Watching numbers scroll by on the serial monitor works fine for 5 minutes, but how do you explain trends to a farmer after a week, or detect subtle changes before they damage crops? This is where cloud storage and visualization come in. Instead of treating data as disposable readings, we capture it as a time series and then use dashboards to translate those values into clear graphs, gauges, and alerts. In this lesson, we'll explore how IoT platforms store, organize, and visualize data, and how you can turn your ESP32 into a system that doesn't just collect numbers but delivers actionable insights you can act on immediately. Every sensor reading is meaningless unless tied to a moment in time. 28 degrees Celsius doesn't tell you much, but 28 degrees Celsius at 2 p.m. compared to 22 degrees Celsius at 6 a.m. starts to reveal a story. That's why IoT platforms treat data as a time series, streams of values indexed with timestamps. These platforms handle rapid, repeated writes more efficiently than a traditional SQL table. Picture it like a diary. Instead of rewriting the same page, you add new entries every minute. Cloud systems make this diary searchable, so you can quickly retrieve last hour or last week. Once you understand that the platform's core job is to timestamp and archive every sensor update, you'll start designing your ESP32 code around efficient publishing intervals instead of blindly dumping data. Different IoT platforms implement storage in their own way, and choosing wisely can save you headaches. ThinkSpeak uses channels, with each channel storing multiple fields like temperature or voltage. Adafruit.io works with feeds, where each feed is a dedicated stream for one variable. Firebase organizes data in gesso-like trees, better for mobile app sync than raw analytics. AWS IoT Core doesn't store much by itself but pipes data into services like DynamoDB or TimeStream for serious scale. The important part is recognizing the data structure and limits. For instance, free ThinkSpeak only lets you log every 15 seconds, push faster and your data gets throttled. That's why you need to ask, does this platform just need to log values, or will I later analyze and predict from it? Here's a quick comparison of popular platforms. Mosquitto isn't a storage system at all, just a broker, so it's best when paired with local logging. ThinkSpeak is lightweight, free, and perfect for academic projects or quick proofs of concept. Adafruit.io offers beautiful dashboards and is hobbyist-friendly. Firebase excels when your IoT project needs tight integration with mobile apps. AWS IoT Core is the heavyweight, excellent for industrial projects but overkill for small prototypes. This table isn't about memorizing features, it's about training your mind to match the tool to the project. Think of it as a decision map: lightweight demo, Go ThinkSpeak, hobby dashboard, Adafruit, production, AWS. Visualization is where your project stops being raw numbers and starts becoming useful to people. A line graph can show temperature rising steadily over hours. A gauge can show humidity dropping below safe thresholds. Think of dashboards as translators. They speak human while your ESP32 speaks raw data. In one project I did for a cold chain supply company, the raw log of numbers didn't impress management. But once we plotted line graphs, the dips during transport became obvious and action was taken immediately. Your role is to configure feeds and widgets so that stakeholders see problems at a glance, not after scrolling through a spreadsheet. Always ask, what visualization helps someone make a decision fastest? Here's where many learners go wrong: sending too much data too often. Publishing every second to ThinkSpeak will hit limits quickly and drain battery if your device is remote. For most environmental monitoring, one update every 30 to 60 seconds is more than enough. Another mistake is mishandling time zones. Always log in UTC and only adjust when displaying. And don't get dazzled by free dashboards alone. Think about whether the platform can handle scaling, alerts, or API integrations you might need later. From my experience, always keep a local backup log, whether on SD card or flash, because cloud outages or network drops are inevitable. The cloud is powerful, but resilience comes from redundancy. In this lesson, We unpacked how IoT platforms turn ESP32 sensor readings into timestamp data streams and dashboards that people can actually use. You now know how time series storage works, how popular platforms differ, and what pitfalls to avoid when logging or visualizing your data. More importantly, you've seen why dashboards matter. They aren't decoration, they're decision-making tools. As you move into practical labs, you'll apply this knowledge by pushing data from your ESP32 to a chosen platform and building visualizations that tell a clear story.